Hello and welcome to our fifth lesson on this metals and non-metals topic. Last lesson we looked at the reactivity series. Today we're going to be looking at displacement reactions. So as you would do for any other lesson, could you write the title in your book please? Displacement reactions. Could you have a read of these learning objectives or listen as I state them out. By the end of this lesson you should be able to state which metal is more reactive using the reactivity series. You should be able to predict if a pair of substances will undergo what's called a displacement reaction, and you should be able to explain why a displacement reaction may or may not take place. So the title is Displacement Reactions, write that in your book and we can make a start. So before we start today's lesson, I just need to refresh your memory from an earlier topics that you have covered. So our first keyword today is the word element. An element. Now an element is a substance made up of only one type of atom. Okay? So an element is a substance made up of only one type of atom. Okay, so that's a 1. I didn't write 1 because I know I wouldn't have space there. Now, elements are found on the periodic table. Okay, so an element is always found on the periodic table. Okay, if we think some examples of elements that are found on the periodic table, we've got some non-metals, so e.g. we've got oxygen, we've got carbon, we've got iodine, and we've also got some metals such as copper, iron, gold, lithium. These are all examples of elements because they're only made up of one type of atom. So oxygen molecules, or oxygen as a substance, is only made up of oxygen atoms. Carbon is only made up of carbon atoms. On the other hand, we have got what's known as compounds. Compounds. Now, a compound can be defined as a substance made up of two or more types of atom, chemically joined together. Chemically joined together. Okay, so a compound is a substance made up of two or more types of atom chemically joined together. Now these are not found on the periodic table, so not on the periodic table. So if you've got a compound and you can't find it on the periodic table, it is a compound. If you've got a substance that you can find on the periodic table, it's not a compound because compounds are not found on the periodic table. Some examples of compounds include, so e.g. we've got carbon dioxide, we've got water, we've got sand. These are all examples of compounds. Another good example would be air, the air around us. Oh no, air is a mixture, sorry. So we could add to that methane. Apologies there, I almost made a very grim mistake. Now, that brings us to what we've been talking about recently. We want elements such as copper, iron, gold so that we can use them. But oftentimes, these elements are found as compounds in nature. Now, one good example that I've prepared, is copper. Copper is found in a rock, usually found in rocks as part of a compound. So we can say that useful elements are often found in compounds. Okay? And we can say that copper is found in rocks in the earth, or in the Earth's crust. Okay? Now, we need a way of extracting this. Okay? So we can just put in red, to use the copper, comma, we need to extract, or it's a posh way of saying remove, the copper element from the compound. Okay, so we've got copper trapped as a compound in this rock. We want to remove that copper so that we can use it to make pipes in plumbing, so that we can make electrical cables, so that we can use it in cooking pans. And today we're going to look at how we do this. Okay? So I'm going to refresh the screen. We're going to start off with a definition. So I am going to need a green pen. And if I can just quickly turn my notes. So our next keyword is the word displacement reaction. Displacement reaction. Okay. Now a displacement reaction can be defined as the following. In a displacement reaction, comma, a more reactive metal, displaces, which is a posh word for saying pushes out, or pushes out a less reactive metal, from a compound. Now that's a long definition and it seems quite difficult, but we'll explain it. So in a displacement reaction, a more reactive metal displaces or pushes out a less reactive metal from its compound. Now, to predict if a displacement reaction will take place, you need to use the reactivity series, which we spoke about last lesson. So we can just put underneath here, and I'm putting it in red because it's important, that the reactivity series can be used to predict if a displacement reaction will take place. If a displacement reaction will take place. So if we think back to last lesson, and I quickly write down our reactivity series. So the reactivity series I will put in blue. So here's our reactivity series. Reactivity series. We said that it starts with potassium. We've then got sodium and lithium. Sodium, lithium, calcium. We've got magnesium, aluminium, zinc. Magnesium, aluminium. We've got zinc. I'm going to have enough room. Iron, lead, copper. Iron, lead, copper. And then we've got silver and gold. Okay? So silver, and I'm not going to be able to fit gold on, but you should be able to see that from yesterday's lesson. If we bring back our picture from the previous slide, so our copper compound, and we make it small, we had the problem of needing to remove this copper from the compound. Okay? We can use a displacement reaction to do this. So inside the rock, the copper is bound to sulfur to make a compound known as copper sulfate. So copper in the rock is bound to sulfur, making the compound copper sulfate. We want to remove the copper from the copper sulfate. Okay? So we can say we want to remove the copper from the copper sulfate. Okay, now we can do this by reacting the copper sulfate with a more reactive metal. So we can do this by reacting copper sulfate with a more reactive metal. A more reactive metal than copper. So if we have a look at our reactivity series, copper is down here. The only two elements that are less reactive than copper are gold and silver. Lead, iron, zinc, aluminium, magnesium, calcium, lithium, sodium and potassium are all more reactive than copper. Therefore, all of these metals will displace copper from the compound. So we're going to use instead iron. So if I take some iron and I react it with the copper sulfate, a reaction will take place. Now, because the iron is more reactive than the copper, the iron will replace the copper to make iron sulfate. So now, instead of having copper sulfate, we will have iron sulfate, and we will have the copper on its own, which we can use. So if I wanted to react and I wanted to get this copper out of this rock, I could first of all break the rock down, add some iron to it and heat it up. I would then get a displacement reaction where the iron replaces the copper because iron is more reactive. Okay? So just for your reference, going back to what we said in the first slide, and I need to find an appropriate colour. This is an element and copper is an element. Copper sulfate, because it's got two parts to its name, is a compound, and iron sulfate has two parts to its name, so that is a compound. And we can say finally, in red, that because iron is more reactive, it displaces the copper from the compound. Because iron is more reactive, it displaces copper from the compound. So this is a displacement reaction because a more reactive metal, iron, has pushed out the less reactive metal, copper, from the compound to make iron sulfate and copper. You must always use the reactivity series to work out if a reaction will take place. So I'm going to refresh the screen. I'm going to write down the reactivity series again for you, and I'm going to ask you to finish off some reactions to say if a displacement reaction will take place. So the reactivity series again. Reactivity series is potassium, sodium, lithium, calcium, magnesium, and then after magnesium we have got aluminium, we've got zinc, after zinc we've got iron, we've got lead, we've got copper, we've got silver, and we've got gold. So I would like you please to have a go at finishing these word equations. Okay, so finish the word equations to predict if displacement takes place. If displacement takes place. Okay, so the first one we're going to do is potassium plus calcium oxide. Pause the video now, see if you can finish off that word equation. Make sure you got a different coloured pen to hand, press play when you're ready to go over the answer. So you should have paused the video, you should have had a go at that word equation, you should have a different coloured pen to hand. So the first thing you should have drawn was an arrow. Remember, we do not put an equal sign. If you put an equal sign, it's wrong. Potassium is more reactive than calcium, so we would end up with potassium oxide, and we would have calcium on its own. Let's try another. So this time you're going to react together zinc and lead nitrate. Lead nitrate. Pause the video now, finish off that word equation, press play when you're ready to go over the answer, make sure you got a different coloured pen. So you should have had a go at that by now. You should have a different coloured pen to change your answers if you need to, mark it. Remember, we always draw an arrow. Zinc is more reactive than lead, so this time we would have zinc nitrate plus lead. Let's try another. So this time I want you to do magnesium plus potassium oxide. Potassium oxide. Think about this one. Pause the video, have a go at it, press play when you're ready to go over the answer. Okay, so you should have had a go at that. So this one's a bit more difficult. Remember, you must always put an arrow because that shows a reaction's taking place. Potassium is more reactive than magnesium. Therefore, magnesium cannot displace it. So what you would end up with is exactly the same. You would have magnesium plus potassium oxide, because potassium is more reactive than magnesium, therefore a reaction would not take place. So our final one we're going to talk about, and I've picked this one for a reason, we're going to do aluminium plus iron oxide. Pause the video please, have a go at it, make sure you've got a different coloured pen to hand so that we can go over the answer in a moment. Okay, so you should have had a go at that one. Again, as always, you should have drawn an arrow because that shows there's a reaction. Aluminium is more reactive than iron, so what you would be left with is aluminium oxide plus iron on its own. Now this is a very special reaction. This is what's known as a thermite reaction. Now a thermite reaction is really useful. We can use thermite reactions to weld railways together. This last one, this aluminium plus iron oxide, is very, very explosive. Here's a picture of a thermite reaction taking place. It's a displacement reaction that is used to weld areas of the railway together, as well as lots of other uses, and we're going to define it. We're going to define what a thermite reaction is. Okay, so our final keyword today is thermite reaction. That's THERMITE reaction. A thermite reaction can be defined as a displacement reaction where aluminium replaces iron in a iron oxide compound. So that is a very, very useful one. I'll leave you guys to research what a thermite reaction is and how it is useful. So as we do for any other lesson, we're going to finish off with some questions. I would like you to have a go at the questions, please. They are on the PowerPoint if you can't wait for me to add them here. I would like you to have a go at the questions, write them out in your book, please. I would then like you to press play on the video again. Make sure you got a different coloured pen, preferably green, but it doesn't really matter. And we will go over the answers. So have a go at questions 1 and 2. Pause the video now and we will come back together. So, you should have had a go at those by now. Let's go over number 1. So it says, copy the sentences below, correcting the 5 mistakes. Now, how's the best way? It's probably best we write it out. So, your sentence should have read, in a displacement reaction, so in a displacement reaction, comma, a more, so this was wrong, a more reactive metal pushes out a less, and that was another mistake, reactive metal from its compound. Metal from its compound, full stop. You should have then said, for example, aluminium displaces iron and that was the fourth mistake, from iron oxide, and that was your fifth mistake. So if you corrected the sentences properly, it should have read, in a displacement reaction, a more reactive metal pushes out a less reactive metal from its compound. For example, aluminium displaces iron from iron oxide. So, question 2 says, predict which pairs of substances will react, give reasons for your decision. So, reaction A, you should have said that there will be a reaction because zinc is more reactive than copper. So zinc is more reactive than copper. For reaction B, you should have said that there is no reaction. Okay, there wouldn't be a reaction. So there wouldn't be a reaction because zinc is more reactive than iron. So zinc more reactive than iron. Aluminium powder and copper oxide, there would be a reaction because aluminium is more reactive than copper. And finally, D, you should have said that there will be a reaction because iron is more reactive than lead. So this was for 8 marks. You get 1 mark for saying if the reaction would take place or not. So for A, there would be a reaction. B, there wouldn't be a reaction. C, there would be a reaction. D, there would be a reaction. And you get the other 4 marks for saying why. So A, there will be a reaction because zinc is more reactive than copper. For B, there won't be a reaction because zinc is more reactive than iron. C, there will be a reaction because aluminium is more reactive than copper. And D, there will be a reaction because iron is more reactive than lead. So if we have a look back to our learning objectives, you should now be able to tell me which metal is more reactive using the reactivity series. The higher up it is, the more reactive it is. You should be able to predict if a pair of substances will undergo a displacement reaction. You can use the reactivity series to do that. And can you explain why a displacement reaction may or not take place, depending on if an element is more reactive or not. I hope this lesson has been useful to you. If you have any questions, please comment below in Google Classrooms or send me an email directly and I will get back to you as soon as I can. Until the next video, take care.